CMMS Radio talks about all things CMMS, computerized maintenance management software, focused on maintenance management. It's the people, the process, and the culture that make your CMMS journey a success.
Now to get started here with our session, we have Corey Dickens, Senior Solutions Consultant at Brightly, a Siemens company. He is going to be speaking today on Maintenance Matters, Key to Unlocking Smart and Sustainable Manufacturing. Please enjoy.
Thank you. I gotta be honest. I'm disappointed. I'm disappointed because this topic is so embedded in me and I'm so passionate about it as a maintenance reliability professional, and yet for 60 years, we still kind of rehash the same conversation. It doesn't seem like we've really progressed the conversation. We have societies built up, we have strategic alliances, all of it to cement maintenance and their impact and value to a manufacturing organization, and yet 2025, here I am. So thank you for joining me today. I hope that together we can talk about this topic, make some progress, take you back to your organization, and implement some changes. Hopefully next year we can talk about your success story and less about rehashing the same conversation yet again. Maintenance to me is a building block of which all the other functions of your business are also building blocks, and now you can start to build on top of those. And once you get to a point of a solid foundation, you can get to the true competitive advantages of your business, which could be sustainable manufacturing and or smart manufacturing. So these are building blocks of which you have to be built on a solid foundation. I've always been taught in presentations I have to give a little bit of a background. So I am Corey Dickens. I am a certified maintenance and reliability professional. That is a ANSI accredited certificate through the Society for Maintenance and Reliability Professionals. It is one of a few out there to help accreditate our understanding of the job that we are tasked with performing and tying it back to an outcome to drive the business forward. Now, I do like to say I'm a recovering maintenance manager. As you can see here, I've worked both on the U.S. Navy on surface ship platforms, taking care of weapon systems like you see there. Those are 3 stories tall, about 250 gallons of hydraulic fluid, a lot of pneumatics, mechanical, electrical, 440 volts, 60 hertz 3-phase, as well as some 400 hertz for servo drive units. After that, I made a stop at a CNC job shop that assembled components for firearms manufacturing. So that picture down there is a live picture of that facility. A few 100,000 square feet, CNCs as far as you can see. And again, we worked in 2 to 4 unit cells. I was not in maintenance at the time. I was in the quality side, quality control and assembly. So firsthand, I started to realize the shortcuts that businesses make and the amount of waste through the processes. After that stop, I went on deployment to Djibouti, Africa with the Navy Reserves. Led a maintenance team of 25 people, did all the administrative oversight in charge of like $13 million worth of sensitive equipment to the government. We did not leave it behind. And then lastly, went to textiles manufacturing. So another kind of dying breed, older mechanical equipment. And my job there was to start creating documentation, start implementing preventive maintenance, start managing our failures, and ultimately be able to report on repair versus replace conversations. Really, we lack documentation and we lack data. So that's who I am. It's what I've done. It's why I think you should listen to me today. Thanks for coming to this presentation. But ultimately, why do I care? Now in my career, I'm a father of 2 little girls. I have a 3.5-year-old and a 1.5-year-old. I live on the East Coast. Came all the way out here to the West Coast. I'm sure my wife is texting me right now about something wild my 3.5-year-old is saying. But that's why I care. I care about leaving places better than when I showed up before. I want to leave my children with a better future and or a maintainable future going forward. So that to me starts to mean implementing sustainable actions or sustainable behaviors. So, Greg, I do know Greg right here. Beard CMMS Radio. What is your definition of maintenance?
Well, number one, it's the act of maintaining.
So the act of maintaining.
Correct.
Okay.
And we're essentially doing a lot of blocking and tackling so as to keep our machines running, in other words, available, and that'll lead to more throughput. But the whole process should first be effective and then efficient, and without maintenance, you can't possibly have that.
So we're support for operations. If
Sure.
you water it down, we can say that, right? What about you? What's your definition of maintenance?
Most efficient use of our assets, being you have to keep up time, but also you cannot spend thousands on replacing parts all the time. So like you have to fine tune that, and that for me that's kind of like what good maintenance should do.
Efficient use of our resources. Love it. All right, I need you to pass it to this gentleman. Now, I'm going to prompt it a little bit here, right? Just like we're figuring out with all these Gen AI tools, it's how you prompt it. So I just blatantly asked the two of you, what's your definition, right? Similar but different. Now, as simple as possible, the definition of maintenance, one or a few words, right? Why more words, fewer words better, and the wise words of Kevin from The Office. But also, think of it of how universally applicable it can be. I'm guessing you own a vehicle. Maintenance on the vehicle. Do you own your own home? Residence. Maintenance of that property. So start to think about that. In as few words as possible, what does maintenance mean?
Working against entropy.
Okay, I like it. I'm going to pull something out from the Oxford Dictionary, maybe. Don't need to point this somewhere. So the root word of maintenance is to maintain. The definition of maintain is to safeguard or protect. So I'm not a big guy, but think of me in front of the equipment in my facility, a knight in shining armor. And my role is to not allow defects or things that can harm the equipment to get past me. That is an act of maintaining. It is to keep defects out of your assets or your systems. It's commonly talked about as a group of people responsible for all actions related to the equipment, right? Which is why I said support. I obviously say we're caretakers. The level of care that we're able to provide depends on resources and support. I must have support to do proactive maintenance. If not, I am reacting and repairing a lot. So, maintenance, the root word to maintain, safeguard or protect, knight in shining armor, and it's to maintain at base condition. The equipment behind you on the whole show floor, if you talk to these OEMs and manufacturers, the equipment is designed to run at a certain rate for a certain duration of time under stated conditions. Now, you, as the operator, the owner of this equipment, can always designate what's called desired performance. Desired performance cannot be greater than base condition. If one of those packaging machines over there can produce 20 packages a minute, right? You cannot feasibly expect it to produce 30 to 40 packages a minute. You must redesign or buy a new piece of equipment designed to operate at that capacity. So we have to have realistic expectations. If we talk about RCM, which is where desired performance comes in, we start assessing and defining the function of the asset, also defining the functional failure of the asset. We'll talk about that more. So, simple question, because you jumped in. Do you work in a manufacturing facility?
I was with automotive.
Okay.
Yeah.
So, your last place, were your assets well maintained? Yes or no?
I'd say no.
Okay. What about you, sir? Are your assets well maintained? Pretty good? Okay. I think there may be something that we'll talk about that I think your team's doing, right? In automotive, we know downtime costs a lot of money. It's the industry that gives that report and statistic, and we talk about it all the time. It's not the same for everyone, right? But again, not well maintained. So what does that mean? Show of hands, who's seen a PF curve before? Anyone seen a visual similar to this? Few people. So the PF curve, there are many variations of it, and there's a lot of kind of bad information you can see in these. I found this very simple one. We got to color code things, right? It's like a stack light. But also there's a few other curves you'll see working against us. Some of our waste in the amount, the cost of repairs, as well as the energy waste associated with an inefficient asset performing, right? So the question becomes, are you maintaining or are you repairing? And again, I want to come back to that root word of maintain and the act of maintaining. The root word of maintenance is different from acts of repairs or acts of correcting performance of the equipment, right? I want to draw a very distinguished line in the sand here because it helps change the perspective of how you look at your organization. Are we maintaining well? Are we performing a lot of repairs? Those are not the same. We can talk about the 7 to 9 types of maintenance, and again, all you hear is maintenance, 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 maintenance. So what do? We blame maintenance for all our problems. We either think it's the act of maintaining is the problem or the group that is tasked with carrying it out. There's still some work to be done, but just simply say, here's my line in the sand. Now this line is not perfect, it is not universally applicable. The intersection between the black degrading curve and the green line, at that intersection, the inflection point is where we have stated functional failure. So if I have one of those packaging machines behind and it's designed to package or tape 20 boxes a minute, as an engineer, I may say at functional failure, I designate when it can no longer tape 10 boxes a minute. It doesn't mean it can't turn on. It doesn't mean only 2 boxes get through. I'm defining the parameters of which I want it to operate with tolerances. At that tolerance, we go from a state of maintaining to a state of repairing. Again, am I now performing an act of maintenance, inspections, time-based replacements, scheduled restoration, or am I repairing? I am reacting, I am not in control. In my world, again in the Navy, we call this function M&R, maintenance and repair, not to be confused with maintenance and reliability. We just simply put both labels that are appropriate to this group of people who perform these actions, because they both maintain and they repair. But instead, we just call this maintenance, and we blame them for everything, right? We're to blame. I'll be honest with you, I've turned a wrench. We're not perfect, but we're getting there. And that's a different conversation that I, being a CMRP, and involved in through these societies of trying to find ways where we can educate the technicians, increase their understanding of our task and our role within the organization. But we also need to come at this from a leadership and a support aspect as well. Can we help guide and challenge these assumptions? Challenge the status quo. In the aviation world, sensitive topic right now, at the very bottom, you start to incorporate replacements or overhaul. MRO, maintain, repair, overhaul. So again, these are mechanisms in which you can operate your equipment. As you see at the bottom, that is catastrophic failure. The asset will not turn over, it will not turn on, it will cease to operate. And again, what do we know about this? The component that led to the failure is now not the only component that needs to be replaced. The stitch in time saves 9. When it crashed, it took other components with it. It may have contributed to a lot of high energy waste at this point, so we're going to see that in our utility bill. And then also it's an unsafe equipment to operate, and operators know that, they feel it instinctively. So how do we maintain this level of being at base condition or desired performance where people feel safe to operate the equipment, they're empowered to report to maintenance when there is an issue so we can diagnose it ahead of time? Because the whole goal of the P to F interval, by this visual, which may be a little bit cleaner, is to maximize that time window there. To again, to act in a manner of which I am still in control of the degradation of the equipment, not waiting till it ceases to operate. That's when we get unplanned downtime in automotive. So the idea here is to collect information about how the equipment fails, how often it fails, and start using that to guide and optimize how we perform inspections, what we're inspecting, and how often we do time-based replacements of certain known wear components. So as you see here, there are a few I intervals. Those are inspection windows. This does not have to be maintenance doing the inspections. This is where we can upskill or reskill our operators to address certain specific failure modes at a set frequency. That frequency is generally set by understanding the mean time between failure for this wear component of this asset or system under conditions. So let's say, for example, my mean time between failure for this failure mechanism is 2,000 hours of operation. There are two theories here. You start with half-lifing or you start with quarter-lifing. I'm a fan of quarter-lifing it, so it means every, 500 hours of operation, I'm going to do a no access needed, still running, non-invasive, non-destructive inspection. And I'm going to inspect the belt, the tension, the elongation of a chain, whatever it may be. I'm going to test it or inspect it at that interval. And the idea here is that within that window, it's just enough time to identify an issue, prioritize the repair, plan it, so fully scope the job, identify the components that need replacement, potentially order those, because you know supply chain is still an issue for some of these components. And then ultimately you need to schedule it with operations. Minimize the unplanned events. So schedule it proactively, be in control, execute the repair, restore it to base condition. That's how you start winning. So the goal of maintenance is to collect enough information to be able to utilize the P to F interval, constantly improving our process and maximizing the available window. The idea here between the inspection intervals, we'll get to in the next topic, but I don't want those intervals to be too large. If they're too large, you're potentially missing valuable time to react to the issue. And if they're too close, you probably never finding a defect. So let's say if your percentage of defect identification is 1 every 20 inspection rounds. That's a low percentage. And again, you're potentially taking equipment offline. You're paying people overhead costs to perform those inspections. It's not needed, it's wasteful. So now we're starting to talk about some waste. I don't consider this efficiency. We'll get to that. Ramesh Gulati is the reliability Sherpa. He is one of the people in our industry that we look to as like he wrote the book for what we're doing and says it very elegantly, right? There's a book, Maintenance Reliability Best Practices, 3rd edition on Amazon. There's also an online course. I highly recommend it for anyone who just wants to understand this at a greater detail. So Ramesh calls us capacity assurance. It is our job to ensure the asset is able to perform its intended function when needed. It's just like quality assurance versus quality control. It's not just a measurement after the fact saying, yeah, we got a problem. What are we going to do to fix it? Quality assurance is proactive in nature of mitigating those risks in real time before they result in an event happening, essentially. If we're doing this and we're optimizing the intervals that we perform maintenance, we're mitigating unplanned downtime, what we're really doing is also reducing our maintenance cost per unit. Now, if I reduce your maintenance cost per unit, let's say 25%, are you going to change the price point at which you sell that product in the market? Nope. So what did we just do? I increased your profit margin of that maintenance or that unit. So now what if I can also ensure capacity is greater than expected? Maintenance directly contributed to both top line and bottom line savings. The goal is to maximize the asset's designed efficiency and reliability. Again, reliability is a design metric in the equipment. You can engineer a higher reliability of your equipment. It's a probability statistic. It says, hey, there's a lambda equation, I'm not a mathematician, but there's a duration of time under stated conditions of a failure rate, and it's a probability the equipment will perform its intended function under stated conditions for a duration of time. That's a probability. Those are design aspects, like design for sustainability, that you can take back to the drawing board. Excuse me. The other type of reliability is in our behaviors and our habits. That's the one we talk about. It's just like quality. Quality isn't just the job of the quality department. Quality is everyone's job. Safety. Safety is everyone's job. Reliability is also everyone's job. Do we have a reliable culture that I can depend on to perform certain actions the right way the first time for reliable outcomes? Right? So it's things like we invest in the right tools and training for our technicians, so if they replace a motor on a drive unit, they do a laser alignment to ensure there's no misalignment that we know would damage the bearings they just installed, scoring the shaft, dropping the pillow block, all the other failure, right? Because again, now we hit catastrophic failure. So what are those things that we can do ahead of time to mitigate those risks from becoming an actual event? And then lastly, we are here as that knight in shining armor to protect the asset's function. Simply stated, it's our job to perform acts of maintenance in the goal of mitigating potential risks to that asset, ensuring the capacity and saving us money, ideally. Who here has heard of a car analogy with almost any presentation? I see the eye rolls, I've done it a million times. This is just a graphic, but we're gonna talk about it because anyone know who JLL is? JLL, the facility management company, kind of competitive with like the CBREs of the world, right? Jones Lang LaSalle did a study a few years ago, it may have been longer, about the ROI of preventive maintenance. And again, we're talking about a facility component, so let's look at like this exhibit hall versus a manufacturing facility. They said there's a 545% ROI to performing preventive maintenance versus always reacting. You got to read the fine print here. It's when we can defer the replacement of the asset beyond its design life cycle. So if you buy one of those pieces of equipment that's designed to run for 15 years at design capacity, and you can get 25 years of efficient use out of it, that's the ROI. It starts to compound. That's the goal of maintenance, is to preserve the life of the asset beyond design use. Perfect example here. My brother is notorious for not taking care of vehicles very well, right? So when he was in high school, he wrecked one vehicle. My parents got him a 1987 Honda Civic, and this was 2007, 2008. 1987 Honda Civic, had the headlights that would come up, right? Perfect condition, mint. Probably still had like 150,000 miles on it. One owner, dude loved it, babied it, right? You give it to my brother for 6 months, one headlight doesn't come out, one stuck up, muffler fell off, got the $30 Walmart subwoofer in the back, crap box, right? You think that's an efficient asset? No. Guarantee you the fuel efficiency is half of what it's supposed to be. Didn't maintain it, didn't wash it. And a car that lasted for 20 years in mint condition, all of a sudden you put it in the hands of someone else who doesn't care for it, it deteriorates in 6 months. It's a perfect example of what we're trying to do and why this stuff is important. Okay. Now, we talked about efficiency a few times. I was upstairs at the keynote, and efficiency was only said 27 times in that as well. Not a knock there, but it's just one of those buzzwords in the industry. Efficiency, efficiency, efficiency. I would argue what you should be chasing isn't efficiency gains, at least not at first. What good is looking for efficiency gains and adding speed on top of a flawed process? Stacking bad habits. So what do we need to do? What we need to do is build effectiveness. We need to find, and it's harder, I know, but we need to figure out how to measure the effectiveness of certain processes, and only once the effectiveness is inherent, and we have now baked it into the process, can we add and look for efficiency gains. I believe that if you work in an organization that does maintenance, I can guarantee right now they are ineffective at their process. And that is an issue that we are tackling, and we're doing through this. They're not using metrics like mean time between failure because they don't accurately track what their downtime events are or duration of events. They're not properly coding that in a tool. What failed? What equipment? What was the problem? What was the cause? They're not doing any level of detail there. And if they do, it's probably in a very cumbersome tool they don't like using. And it's a missing gap when it goes to the maintenance planner. The maintenance planner's asked directly for the reports by the supervisor. They're just filling the gap. Now you can't trust the data, and you're wondering why you're just spinning your wheels. So focus on the direction you're going and the effectiveness of the task before you apply speed. Perfect example. Greg, I'm going to pick on you for this.
Sure.
So you're hiring for a role at your organization, right? I'm interested. I apply. One of your basic qualifications is must have good math skills. In my resume, I say I'm very fast at math. Right? Ask me a math question.
Well, I would ask you what's 727 divided by 7.
Was that right?
I couldn't tell you if I had
Not
to.
even close, right?
Yeah.
I never said I was good at math. I just said I was fast. Think about that. Think about the habits of people within your organization that you're trying to find efficiency gains. They're sitting there like, I don't know why I do this. I don't know what benefit this has. I don't know how it helps us. I'm told to do something, I do it. and then I have a reliability engineer or continuous improvement specialist coming right behind me saying, hey, I can cut half that time out. Great. Half the time, same terrible end result. So focus on the effectiveness first. Again, I'm not telling you to not measure the efficiency of certain things. Let's look at OEE. People twist that metric and they're able to modify it a lot to get the desired end result. It's like Elijah Goldratt said, right? Show me how I measured, I'll show you how I perform. Be careful. Practice doesn't make perfect. I was told this so many times playing athletics growing up. Practice makes perfect. Practice makes perfect. No. It makes permanent. You want to know why instituting change is so hard in your organizations? You're going against 20 to 30 years of bad habits that have been reinforced. It's going to take some work. You got to go back to the building block. Why are we doing this task in the first place? And is this the most effective means of performing this task? Does it have the desired outcome? Only then can we apply speed. These are the types of waste that you're going to see in a typical manufacturing organization. The 5 that are highlighted are ones I can pinpoint right now that are happening with your maintenance group. Right? They're not preventing defects from entering the systems. They're not the knight in shining armor. They're just repair people. Waiting. How many of them have to wait around for access because, yeah, we may have had a PM scheduled and operations agreed to it a month ago. It's 2 days before and operations says, nope, the equipment didn't run how we needed it so far. We got to get this shipment out. We deny you access. Unused talent. Think of your senior technicians. They've been there. They wrote the book for 40 years how to do these tasks. But again, in the next 5 years, they're going to go fishing full time. What are you doing to capture that information now about how the equipment fails, how often, what are my repair actions or procedures? Troubleshoot. Inventory. This is when I can give you a statistic till I'm blue in the face. Inventory, if you don't have an organized 5S, 6S inventory management process, a maintenance technician on average will spend 20 to 30% of their day just looking for the part on the shelf. I see a few nods already. I was there. I walked into an organization that had a parts cage. I couldn't lock that parts cage and control access. Why? Because the breakers for that building were also in my cage. I don't know about you, but I had pretty flexible work hours. I didn't want to beat operations there to just unlock a cage for them, right? So things, 5-finger or sticky discount, 5-finger discount, things grow legs, walk away. They have their little hiding spots. Again, get back to, hey, do I have a tool where I could organize this? Even get down to the bin level, QR code that bin, and giving that information at the equipment versus doing the shuffle back and forth to the office to get on a computer or ask someone who may know. I had that guy. John was my engineer. John knew where everything was. He was a hoarder. Oh, it's on this pallet in this box on this rack of shelving back by quarantine. Oh, no, you're right. I moved that a few weeks ago. Where did I put that? Get it organized. Now we're applying speed to an effective process. Lastly is that motion. Again, this is the time spent wandering the facility. You see these types of waste all the time. These are always the ones we flock to and say, how can we do a value stream map or value stream map it and figure out how to make this process more efficient? But again, is it built on good habits? Is it built on an effective process? And I can guarantee your maintenance organization is not. All right, Corey's got to take a little bit of a breath. Recap. I challenged your definition of maintenance already. I know some people miss that, don't worry. Maintenance is the act of maintaining. It's to safeguard or protect the asset in desired performance or at base condition. What is desired performance? What is base condition? Well, it's either designed that way or an engineer assesses it and it cannot be greater than the design operating parameters of the equipment. So define that. And then define through like a failure modes and effects analysis, nothing too deep, you can go one by one, how can this asset fail? What mechanism or failure mode introduces and leads to a failure, functional failure? Define that, implement some ways to protect that from happening. Now you're maintaining. Slow is smooth, smooth is fast. Again, I'm a military guy, I've handled weapon systems my whole life. You can't just grab a weapon for the first time and think you're going to be a marksman or an expert marksman, right? You have to build fundamentals, and then only then can you start getting faster and faster. I love this visual for that. I almost think when I see that, I thought of Ted Lasso, right? He's playing darts. So again, I'd rather be bullseye every time consistently and effectively than 1 for 5. Now the difference here is, again, we talked about those inspections and the rate of inspections and the frequency between those. I'm comfortable, honestly, with a task failure effectiveness metric of 1 every 4 to 5 inspections. You don't want 1 every 10. You don't want 1 every 1. If you're finding a defect present every time you do an inspection, you're not doing inspections often enough. If you're not finding it ever, you're addressing the wrong failure mode. You're not looking in the right place, or I may not be going to the equipment and actually checking. I'm just checking off the work order. It's another problem. And then add speed to an effective process. You can use the Deming cycle. I'm a military person, so I love the OODA loop: observe, orient, decide, and act. Use whatever's comfortable and you're familiar with. All right. We're going to add some speed now that I've got the foundation set. Anyone ever seen one of these graphics before? I never saw it until doing some research for this. Again, at my company, we're a software company. We do asset and maintenance management solutions. We also do a lot of sustainability stuff, right? So that gets me into the realm of, okay, well, if the asset's designed to have a certain design load on it, and we know there's a certain amount of the conversion to waste for that consumed net energy intensity, right? The Department of Energy has diagrams for different NICS codes of your industry and those typical processes and non-processes, the input of the energy sources, and then the converted waste factor. So in this example, this on-site emissions is the 5 MMT CO2e, right? Whatever that is. I didn't research that. It's the only thing I didn't research. But again, you start looking at all the inputs, and then you say, okay, now that I know we're taking care of equipment and it is both effective in our task, but then we can operate the equipment efficiently, what areas of improvement can I see? Also, devil's advocate, how much more waste are we generating because of an inefficient asset? Anyone in here involved in sustainability projects at your organization? Anyone done any yet? All right, well, none. I can guarantee you the first one that someone's going to ask you to do. It's going to be a lighting project, right? Motion sensing lighting in your facility, because they think that's the first place to start. It's a quick win, don't get me wrong. It's a great place to start, and it builds some value. It's not a ton of value. Next, you may start to look at some of the rooftop ventilation or rooftop air handling units, right? And controls for those and a smart facility, and that's great. But again, now you can get to the machine drive components. Now you can get to the process waste. These type of graphics are going to give you a good idea. Can I buy a similar type of equipment, but at a more sustainable, like with more design for sustainability features? Is it a more efficient unit? And I'll reinforce this here in a minute. I just thought this was really interesting, and I want to bring it up because now we're starting to talk about managing the entire life cycle, not just of the asset, not just of the system through proactive maintenance. Now we can start to have holistic management view of every kind of inflow of energy and the converted waste of those, and how do we optimize that process. But again, it must be built on good habits, or else you're just spinning your wheels. Did a silly question segment earlier, and I asked a few people to define maintenance. Now we're going to talk about sustainability. So she has a microphone. I'm going to put up a visual. Anyone want to take a stab at one word what sustainability is? Greg, you want to try it?
Efficiency.
Efficiency, okay.
Environment.
Environment. One more person. You want to take a stab? Anyone in the back? There's 3 that I've touched on throughout this entire presentation. Starts with zero waste, waste identification, waste elimination. We talked about the ROI of preventive maintenance. What is the ROI? What is the objective of preventive maintenance? It's to defer the replacement of the asset to ensure it's able to perform its intended function efficiently for a long period of time. And then lastly, it's the name of the presentation, It must be well maintained. So again, if you want to see how we tie all of these actions back to sustainability initiatives, these 3 words or 3 terms here can be applicable to every project you do that's sustainability focused. It's the same 3 things we're trying to do with maintenance. We want to protect the asset from defects that create waste. We want to ensure and maintain the asset for a long life. And through that, we're performing acts of maintenance, which ensures you can turn that question from, are your assets well maintained, turn that into a yes. That's what we're trying to do. I don't know why the words kind of stacked up there. If you're looking for social proof, I know I was. I went with my title, Maintenance Matters, and I Google searched it. Well, what came up was a YouTube short of a podcast. So this is the podcast, the 360 on Energy and Carbon podcast. They're out of Canada. They are very big on the sustainability front. But I thought it was interesting because this guy used to run his own manufacturing facility as an engineer. And he talks about, the first project we did, lighting. Second project we did, heat, a few other things, right? And then he got to a point where he was working with the utility provider for funding to replace the pneumatics for their system, right? They had a 20 horsepower air compressor. Well, they had an energy audit done, and the engineer said, hey, Paul, you really only need about 10 horsepower. Great. Half the capacity, half the energy use, right? We didn't stop there. Half the energy use is one thing, because it had some other smart features about it, and sustainability features. As a screw compressor, generally they're notorious for just running flatline, right? Well, he's able to find one that would actually shut off during certain periods of days, like they could schedule it, almost like an HVAC unit. So that saved even more money on energy. But that wasn't even the big kicker for him. It was the reduced maintenance cost to maintain it. He said, what we could track, because we started becoming smart and documenting things, $7,000 a year to maintain the air compressor they were operating. That was twice the capacity that they needed, right? New unit, $2,500 a year. Cheaper than what he was already paying, and he probably outsourced it, right? May have been in a warranty period. He now has a justification for that. So save $4,000 on energy cost, save $4,500 on the maintenance cost per year, right? So you start stacking this, and that's just one piece of equipment. Now we start doing another one, and another one, and another one. I thought it was interesting because Lysandra, the moderator, immediately after jumped in, said, you know what, I'm an engineer, and I've been a maintenance planner before. And it's interesting you say this because we schedule all this maintenance. We walk into an organization, there's a set way of doing maintenance and a set way of doing this. We issue the work orders with certain tasks, but we never really ask the question, is it effective? Why are we doing this? So again, challenge the assumptions, the status quo previously, and get back to, is it effective? If it's not, I'd challenge it and maybe find a better alternative, a more effective means of performing the same task, maybe addressing the right failure mode. I highly recommend checking this out because it also gets into the data-driven aspect. Because Paul said, hey, bring up your top 10 equipment cost centers. What assets are costing you the most to maintain? Now you can kind of start plucking out big ticket items one by one. What can we do to improve this? Is the maintenance we're doing, are they effective? Is the asset therefore efficient? How is it compared to its life cycle? And ultimately, what are the other options for replacement on the market? I have a client who's a large plastic injection molding, something or another, very well-known brand. And talking to their maintenance director, he said, using the tool, I was able to find how the equipment failed. And when we came back up to design or procure a new one of these thermoformers, I was able to take the information and go back to the design team and say, I need to design for 25% greater structural integrity in these 3 components. Higher quality materials, whatever it may be. And what did the OEM come back and say? No, we did all our testing, it shouldn't fail right there. He's like, well, based on the way we operate, it does. So now I have the data to buy an asset that's built for how we operate it. So no longer buying stuff just off the shelf and slapping it on and say it's good to go. Use the data to your advantage. And that's why maintenance should matter more to you, should matter more to your business. And that's how we connect it to both sustainable manufacturing, sustainability in general, but also smart manufacturing. Just operating and collecting information and the right information and doing something with it. What good is all the data in the world if you don't know how to turn it into action? So that's my challenge. We know that a well-maintained asset is more efficient use of the resources. It's safer to operate. It reduces your costs or your maintenance costs per unit, and ultimately it can be sustained for longer. It's not going to be easy. People are going to resist. Again, you're fighting against the grain of a culture embedded in 20 to 30 years of these kind of bad habits. So get back to the effectiveness of the task at hand and then apply speed. That's why I think maintenance matters. That's why maintenance matters to me, and I hope it matters to you. Thank you.
Well done, Corey.
Very
Good
much,
job.
Corey. Does anyone have any questions? We have a little bit of time for the next session.
Uh-oh.
So, Corey, later on, you're going to be on the CMMS Radio Live panel on the same stage. And one of the things I was considering over the last several days was that definition of sustainability as part of our presentation later today. And I wanted to ask you, how would you answer that with one word? What is sustainable?
How would I define sustainability with one word or one term?
Yes, sir. One word.
I mean, to me, it just means reduce waste. It's not one word, it's two, right? But that term itself is just, it's a more efficient use of our resources. Anything is a resource. Humans are resources. Their time are resources. Money is a resource.
I would have said that exact same thing if I wasn't limited to one word, so that's excellent.
One word is hard. That's why I had a prompt, but thank you for that.
Yeah.
Any other questions? Okay, well, thank you very much. Oh, sorry.
Just curious, in your experience, are you able to quantify the cost of the lack of culture change, how it costs the company if there was no effort made to make the process more efficient or focus on sustainability?
Far too often, I challenge what our benchmarks are set at. There's, especially in the energy and sustainability world, you do a lot of normalized performance for a normalized baseline. And you run that as a trend analysis. And I talked about this, Greg, early in our friendship, right? Is understand not just what you expect, what is the best practice, right? Because there's always a difference between in practice and best practice. It's our job to meet in the middle, find what's most viable for us. You have to collect enough information to create a new baseline, a normalized performance baseline, and then say, this is trending down. And if that's not a good thing, you got to show projection what that's going to be in 12 months. If we don't change anything, we just keep going through the motions like we are now, this is my prediction of where we're going to be in 12 months. And it's all relative, right? So again, minimizing cost. The assets are designed to work at a certain level and produce a certain amount of trinkets at a certain price point. All that's designed, right? It's a very smart thing that engineers do. But utilization of the asset is much different. So that normalized performance becomes that utilization baseline, and then any improvement from there is an ROI. We can always chase that new benchmark, but normalized performance is how you're operating now, and that's always what we're striving to improve upon.
Anyone else? Okay, well, thank you very much.
Thank you so
Corey.
much. I'll be around the rest of the day.
Did you find this episode helpful? Please send us some feedback, suggest a topic, or ask a question. Reach out to CMMS Radio if you need a co-pilot on your CMMS project. Visit cmmsradio.com and use the What's on Your Mind link. Thank you for tuning in to CMMS Radio, your resource for all things CMMS, from selection to implementation, to help you make better choices, learn from industry experts, and have a successful CMMS journey.